Good day, grade 12s. Welcome to Technical Mathematics. Today's lesson is mensuration. We are going to be discussing mensuration. Now, before we can start with our lesson, I just want to make sure that every learner has examination guidelines, a very important document. Please make sure that you do have that document. Just go through it and check what is important information that you need to know for each topic under technical mathematics. All right, and then also you must check this one of mensuration. Is there anything that you need to know before you can write the final exam? Then remember this, it's one of the topic, very interesting, and then we are going to discuss it today with you. And then let's start and see what are we going to be discussing. And then under content we have mensuration, and then we should also remember this topic is form part of paper 2. Then under mensuration we are going to be discussing what the surface area and the volume, and the last point we'll be discussing what the mid-ordinate rule. So those are two concepts that we are going to be discussing for today's lesson. So just to make sure that you understand around the surface and the volume, you also understand around the midpoint ordinate rule. Remember, this one is where we are calculating the area of a regular figure. We should also learn that one because it will always be on a question paper. You will be able to, there will be a question if we don't have area, they will ask you to calculate the area. So you must be able to know that. Then the surface area and the volume, what is important that you need to know. You need to know all the formula for the surface area of all the shape that we're having, the volume as well. You must be able to know the formula because on the formula sheet we don't have the formula for surface areas and the volume. So let us make sure that we revise everything. When you talk about the cylinder, when you talk about the cone, the sphere, the pyramid, so you must know all the formula for those and then the volume as well. So it's very important. And then remember, we have done this mensuration last year when you're in grade 11. So it's going to be just a revision to us, and then we also have to revise it because it's going to be part of the final exam. So let us make sure that we do our best. And then let's start. Now the surface area. It said calculate the surface area of the cylinder given your answer in a centimeter square. Now look at the figure that we're having there. Our radius is 10 millimeter, but they are saying the question should be, the answer should be in terms of centimeter square. Then the area, the radius is 10 millimeter, while the height is 20 millimeter. So meaning we have to convert first. We have to convert first because our answer is needed in terms of centimeter squared. Now let's see. We have to convert millimeter to centimeter. Therefore, 10 millimeter is equivalent or is equals to 1 centimeter, and then 20 millimeter is equals to what? 2 centimeters. So how did we obtain? We know that 10 millimeter you divide with 10 to get centimeter, 20 millimeter you divide with 10 to get centimeter. So this is what are we going to be using: 1 centimeter and 2 centimeter. Then you write the formula for the surface area of a cylinder equals to 2 multiplied by pi r squared plus 2r times height. Now the value of r is 1, which is radius, and the height is 2. Then just press your calculator. Then it's going to give us 18.85 centimeters squared. So it's also important that you should write the units just after calculating. Use the units so that we can be able to see what were you calculating. So in this one, we are calculating surface area. So hence it says centimeter square to show that we are calculating the area. Calculate the surface area of sphere with diameter of 3.5 meter. Correct one decimal place. Use pi as 3.14. Now, what you see here, this is not a hemisphere. It's what? This is a sphere. But since we know that hemisphere is half of sphere, then meaning we are going to calculate the surface area of this, the half of this ball. So maybe this portion here, we want to calculate the surface area, half of this ball. Now let's see on how do we do that. You first write the surface area of a sphere, but if you times by half, since hemisphere is half of what? Sphere, then this is going to be the surface area of sphere, right? And then from there you then substitute the values. But now remember, we are given what? We are given the diameter. Hence you say instead of r, you just say 3.5 over 2 because radius is half of diameter. But and then pi, we agreed that we are going to use 3.14. Then from there, you press everything on your calculator, then 19.2 meter squared. So this is also very, very important. This instruction that say correct one decimal place. So it must be like that. So you must write to one decimal, one number after comma. All right, and then your units as well. Units are very important. So this one is meter squared. Find the height of the cylindrical tank if its volume is what? 300 cubic meter and its radius is 3 meter. Round off your answer to 2 decimal place. Now in this one, we are in need of height. We want the height. We want to know from this point up to the bottom there, what is the height? In this case, we are no longer calculating the volume. We are giving the volume in this time. Now we have to calculate what the height. You write the formula for volume of a cylinder, which is this, all right? The second step, you're going to substitute the volume is 300 and the radius that we have is 3 meter squared in the pi. But because we're in need of this h, then we're going to be having this and then we divide with pi 9 or 9 pi is what we're having. Then you can just press your calculator and the answer that we're having is 10.61 meter, because it was very clear that you should round your answer to 2 decimal places. So it's very important. That's how you should now determine the height. Then next one. The volume of this cone is 7.54 centimeter cubic centimeter, and its height is 50 millimeter. Find the radius of the cone. Give your answer in centimeter and correct one decimal place. Now you can see that we have to give our answer in terms of centimeter. Then look at the height. Look at the height. It is in terms of millimeter. Then we need to also to convert. So meaning you can see that under mensuration, converting is very important. They also test as whether you can be able to convert from one unit to another. So it's very, very important. Now let's look into the solution. Now this is the volume for cone. It's a 1/3 multiplied by the area of a base times height. The area of a base is pi r squared, the height. Now remember, in this one we are giving what? We're giving the volume. We have a volume. Let's substitute the volume. Our volume is 7.54, and then it equals to 1/3 pi r squared times 5. The question needs us to calculate the radius r. Then from there, you are going to multiply each term by this fraction, denominator of this fraction. You can see we are no longer having a fraction because we multiply this fraction with 3. Since we are in need of r, and then we are going to be dividing with 5 pi. After dividing with 5 pi, we get rid of this exponent 2. Then we just we square both sides. You put square root both sides. Then it's going to be plus or minus. The answer is 1,2 centimeter because we don't have a radius which is negative. Then obviously we're going to take the positive one, which is 1,2 centimeter. So that's how you should determine what the radius. Remember, the height was 50. Now the height is now 5. Because why we convert 50 millimeter to centimeter. So we're going to divide this 50 with 10. That's going to give us what? 5. The volume of this sphere is a 524 cubic meter. Find the radius of the sphere. Give your answer to correct to the nearest meters. Now we have a sphere. You can see that's this sphere, a ball, but we don't know what is the radius of this. What we have is the volume of the sphere. Then we'll be calculating the radius. And then let's see on how do we determine the radius. Volume of sphere equals to 4/3 times pi times r cubed. Then you substitute with what? We substitute our volume, which is 524 times 3. Why 3? Because we did not want to work with this fraction. So in order to get rid of this fraction, we multiply each term by the denominator of that fraction. So if we multiply this 4/3 times 3, then it's going to give us 4, because 3 is going to cancel that 3. So that's what we're having. The third step, we are going to be dividing with 4 pi both sides, then we are left with r to the power 3. Now this one, we have to get rid of this exponent 3. So we're going to put the cube root both sides. This is what we're going to have. You just press your calculator, and the value of r equals to 5. So that is the radius, all right? So that is the radius. And we've just determined the radius of sphere. So it's quite simple, quite easy. You just have to be able to know how to make r the subject of the formula. Is very important. All right, and now we say the diameter of the sphere is 12 centimeter. We have the diameter of the sphere is 12 centimeter. Calculate the volume of sphere. Round off the answer to 2 decimal places. Let's calculate the volume of sphere. let us calculate the volume of sphere. You write the correct, but now first, remember we were giving what the diameter, then it's volume of sphere does have radius. So now we are looking for radius of sphere. We divide this with 2 because we know that radius is half of diameter, and then we are now having a radius which is 6 centimeter. The volume of sphere is equals to 4/3 pi r over 3. All right, and therefore we then substitute the values. The r, the radius is 6. Then you can now press your calculator, and 904.78 centimeter or cubic centimeter. You can say that because it's very clear that we should write 2 decimal places. That instruction is very, very important because we cannot be able to lose marks because we fail to write or to round off our answer to 2 decimal places. Let us make sure that we follow and we do exactly in the way the instruction need us to calculate. And then also the units is very important. Number 2, calculate the surface area of a sphere. Answer to 2 decimal place. We are now calculating the surface area of sphere, which is 4 pi r squared. And then r is 6, and then you press your calculator, 452.39 centimeter squared. Now this one is surface area. You can see with what? Squared. All right. The object is made up from a cylinder and a hemisphere. The cylinder has a radius of 10 centimeter and a height of 32 centimeter. Calculate the volume of the object to the nearest whole number. Meaning we are going to calculate the volume of this both hemisphere and the cylinder. Let's see on how do we do that. Volume of a cylinder first. We calculate the volume of cylinder, which is V equals to pi r squared times height. We substitute because from the scenario we are having the height, which is 32, and the radius, which is 10. We substitute the values, and then it gives us 10,053 cubic centimeter. So that is the volume of what? Of cylinder. We are now looking for the volume of what? Of sphere. But the fact that we know hemisphere is half of sphere, we don't have a problem. We can just calculate the volume of what? Of sphere, and then you divide with 2. And then you substitute. And then this is the volume of what? Of sphere. Right? And then if you are in need of the volume of hemisphere, you are going to be dividing this with 2. Then the volume that we are looking for is this. It's 2095 centimeter or cubic centimeter. So after getting the volume of sphere, and then you have to get the volume of hemisphere, and then we have determined as well the volume of cylinder, then we are going to add them together. The total volume of object is, let me check, the total, you add the 2, then you'll get what? You'll get the total volume of what? Of object. It's very important. Now let's proceed. All right. The closed right cylindrical container shown in the diagram below has been made such that exactly 3 identical spherical metal balls fit tightly inside. The interior height, which is h of the cylinder, is 33 centimeter. The interior diameter of the cylinder is 11 centimeter. The radius of the metal ball is 5.5 centimeter. calculate the total interior. Calculate the interior surface area of a closed cylindrical container. Let's calculate the surface area. You write the surface area of cylindrical container. We then substitute what is the value of R is 50. R radius, which is 5,5, and then height is 32. All right, it's 32. And then from there, all right, everything is correct, because remember we are given the diameter, you divide with 2, then it's going to give us 5,5. The third step, just press your calculator, and then it's going to give us 1,330,46 centimeters squared, because we are calculating what? The surface area. Number 2, calculate the volume of one spherical metal. This ball, you can see we only have to calculate the volume of one. Let's calculate, that is the formula for volume of sphere. You then substitute, right? Because it is given that the radius of the metal ball is 5,5 centimeters. Then you just press your calculator, it gives us 696,1991 cubic centimeter. That is the volume. And then number 3, determine the volume of the empty space inside the cylindrical container with 3 metal balls. Meaning we need to calculate the volume of this space there. You can see there is a space there, so that we need to calculate the volume of that space. But the question is, how are we going to calculate that? Now first, we are going to calculate the volume of the cylinder. The volume of cylinder, this is going to be the volume of cylinder, and then it's going to give us 3,136,09 cubic centimeter. That is the volume of the whole cylinder. All right. Thereafter, we then calculate the volume of 3 sphere metal ball. But the fact that number 2, we calculated the volume of 1 of metal ball. To get the volume of 3, you can multiply 3 times this, the volume of 1 metal ball. Then it's going to give us how much? 2,090,70 cubic centimeter. Now, after determining the volume of the cylinder and the volume of 3 metal balls, we are going to minus them together. So we're going to say the volume of the empty space inside the cylindrical container. You say this one minus this one, then it's going to give us 1,045,39 cubic centimeter. So that means that is the volume of this space. All right, this space, which is not occupied by these 3 balls. All right. The area of irregular shape. We are now done with surface area. We are done with the volume. We have calculated surface area. We have also calculated the volume. And then we also learn on how do we calculate the height or the radius if the volume is given or the surface area is given. So you just have to make, maybe if it's a radius, you have to make R the subject of the formula in order to calculate the value of R. If it's h, which is the height, you must be able to make the height the subject of the formula so that you can be able to calculate the height. Determine the area of an irregular figure using the mid-ordinate rule formula. So this is the formula that we are going to be using when we are calculating the area of irregular shape. Area equals to width of interval multiplied by the sum of the mid-ordinates. Now let's have an example and see on how do we do that. Calculate the area of the irregular shape using the mid-ordinate. You can see this is a regular shape. We have to calculate the area of this. Now, how are we going to do that? First, you are going to calculate the mid-ordinates. This one, the mid-ordinate. There's ordinate 1, ordinate 2, 3, 4, 5, 6, 7. We have 7 ordinates. So first, we are going to say the first ordinate multiplied by the second ordinate divided by 2, it equals 1,25 meter. And then you will say the second plus the third divided by 2, it gives us 3 meter. And then the third and the fourth divided by 2, it gives us 4,25 meters. The fourth and the fifth, you divide them with 2, it gives us 4,8 meters. Then you take the fifth and the sixth, and then they give us what? 3,9. And then of course the sixth and the last one, you add them together, it gives us 1,6 meter. After determining the mid-ordinates, you write the formula. That is the formula for area. And then what is the width of interval? Meaning the distance between this ordinates is 10 meter. Then we're going to substitute 10 meter, and inside we're going to add all the mid-ordinate, and our answer is 188 centimeters squared. So you are done calculating the area of this irregular figure. Let's have another example. The irregular figure below has a straight side which is 24 centimeters long, which is divided into 4 equal parts. The ordinates divided, the parts are 12, 9,3, 8,5, and P. The length of P is half the length of the first ordinate. Write down the value of P. This one is very important, and it's very clear that they are saying this P is what? The length of P is half the length of the first ordinate. What is the first ordinate? Is 12. So half of 12 is equal to 6. Let's see if that is true. Yes, P equals to 6 because half of the first ordinate is 6. Number 2 has determined the area of irregular figure by using the mid-ordinate rule. First, we are going to be determining the mid-ordinate. The first ordinate plus the second one divided by 2, it gives us 11.1. You take the second and the third, 10,2 plus 9,3 over 2 equals to 9,75. And then you take the third and the fourth, 9,3 plus 8,5 divided by 2, it gives us 8,9 centimeters. Then you take the fourth and the fifth, which is 8,5 plus 6 over 2, it gives us 7,25. So those are what? Mid-ordinate rule. Those are mid-ordinate. So after determining the mid-ordinate, you write the formula. And then now the challenge is, or the problem is this one of width of interval. You are given the length, which is 24 centimeters. Now, in order to get the width interval, you are going to count how many space do we have, how many of this mid-ordinate, not mid-ordinate but per se, but the ordinates. We have 1, 2, 3, 4. We have 4 equal parts. How many parts? We have 4 equal parts. We are going to say 24. You're going to say 24 divided by 4, because we have 4 is going to give us 6. So it's going to give us 6. Meaning you have 4 equal parts. You divide 24 with this 4, it's going to give us 6, and then we add all the mid-ordinates that we have just determined. Then you press your calculator, it gives us 222 centimeters squared. So that's how you should determine what? You should determine the area of a regular figure. And let's have another one. The irregular shape below has one straight side divided into 4 equal parts. 4 meters apart, the ordinates divided there are 6,2 meter, y 5,1, 4,1, and 2 meter. Calculate the value of y using the mid-ordinate rule if the area of the irregular shape is this. Now in this one, we are already having the area, but now we need to calculate one of what? The length of one ordinate. And then is this one. We have to calculate the length of that. So let's see on how do we calculate the length of one ordinate if we're having area already. Now first we're going to determine the mid-ordinate first. 6.2 plus y divided by 2, it gives us 3.1 plus y over 2. And then you're going to say y plus 5,1 over 2, it gives us y over 2 plus 2,55. And then 5,1 plus 4,9 over 2, it gives us 5 meter. And then 4,49 plus 2 over 2, it gives us 3,45. That is the last what? Mid-ordinate. And then from there, we have write the formula. We substitute the value, the area is 72, the width interval is 4, and then you add all the mid-ordinate. Now, after adding, you can see half plus half, it gives us y. And then after, you can now divide, we have divided both sides with 4, then 72 over 4, it gives us 18. And from there, since we're in need of y, we're going to transpose this 14,1 to the right hand side. Therefore, y equals to 3.9 meters. So that's how you should determine one of the ordinate. One of the ordinate, all right? All right, thank you very much for being with me into this very interesting lesson. I hope whatever that we discussed is going to help you to prepare for this coming final exam. And then let me just leave you with this nice word saying, never give up. Today is harder, tomorrow will be worse, but the day after tomorrow will be sunshine. So let us not give up. Let us work and work now. All right. Thank you very much. Have a nice evening. Bye.